So for question 1, we are given that sine theta is a half, and we want to find the value of sine theta cos 90 minus theta. So we're going to have to use our complementary rules written on the right here. And we notice we've got a cos 90 minus theta. So if we look over here, we have a cos 90 minus theta here, which shows that this cos 90 minus theta can be changed to sine theta, which is what we need to do. So we'll write sine theta times cos 90 minus theta. Well, sine theta is sine theta, and we know that's going to be a half. So let's just keep that as sine theta. Now, cos 90 minus theta is the same as sine theta. Okay, so basically this cos 90 minus theta, the complementary angle, was changed to the other angle on the other side of the triangle, if you can visualize that. So we have sine theta times sine theta, and we know what sine theta is here. So we'll put a half here. This is also a half, and you'll get a quarter for your final answer. So that's your final answer there. So in question 2, we are given that tan A equals 2. Find the value of 2 tan A plus 90 minus A and tan of that angle. Okay, so it's looking like we're going to need this complementary angle rule. So what we know is that tan 90 minus A is the same as 1 on tan A. Okay, and this is the rule that we use to simplify this part here. So let's just write below here. We got 2 tan A, which is fine because tan A is given here. The value is given here. So 2 tan A, that's already simplified. Now tan 90 minus A is the same as 1 on tan A here. So we'll just substitute the tan A here. And we know that tan A equals 2. So we'll just substitute in. So this is 2 times tan A, and tan A is 2, plus 1 on tan A, and tan A is 2, so that will go here. So you've got 4 plus a half, which is 4 and a half, or 9 on 2, and that's going to be your final value there. Okay, so for question B, we've got tan 75, tan 15, and multiplication here. So it looks like the rule we'll use would be tan 90 minus theta is 1 on tan theta here. So 75 could be written as tan 90 minus 15, isn't it? 90 minus 15 is 75 times tan 15. And if we come over to our rule here, tan 90 minus theta is 1 on tan theta. So this is going to become 1 on tan 15 because theta is 15 in the question. Multiplied by that by tan 15. And we can see here, these will cancel, won't it? So you'll get 1 for the final answer. In question C, we've got cos 20 on sine 70. Now we can change this cos 20 to be cos 90 minus 70, isn't it? Because 90 minus 70 is 20. So there's nothing different here. I haven't changed anything. And this is sine 70. And cos 90 minus 70, we can see it's going to be the same as sine 70, isn't it? So cos 90 minus 70 is actually the same as sine 70 on sine 70, which will cancel to be 1, just like that. So let's use our sine and cosine rules, complementary rules to do this. So we got cos 17. We could write it here. Well, cos 17 is going to be the same as sine cos 90 minus 17, rather. I'm jumping ahead, aren't I? Cos, so that's 90 minus 73, which is the same as cos 17. Okay, 17 is 90 minus 73, which means that we can rewrite this as sine 73. So cos 17 and sine 73 are equivalent. So we could actually rewrite this as sine squared 73 minus sine squared 73, which is 0. Okay, they will cancel each other out. It doesn't matter what the value is, they're equal. And when you subtract equal quantities, then you'll get 0.